So domain is X. Specifically, it's X values at work. X values at work. Let me talk about what I mean by X values at work. Let me just scroll through to an example. First actual example in your notes is 4 over X plus 3. Could X be negative 3? No. Why not? Can't divide by 0. So X could be anything else, couldn't it? X could be 3, that'd be fine. We divide by 6. I think. It could be 12, that'd be divided by 15. But it could not be negative 3. Because if X was negative 3, what would you be dividing by? 0. Here's a mother function. We call it y equals root of X. Could X be negative 2? And be real? No. So the smallest thing X could be would be not 1. 0 in that example. If you take the square root of 0, it's 0. These are the only two rules about what doesn't work. First rule is you can't divide by 0. No. That's actually rule 1. You cannot divide by 0. The first example was there to reinforce that idea. I'm actually going to look at the graph of that thing, just so you can kind of see what happens on the graph when we attempt to be negative 3, because you can't divide by 0. I know I get on to y'all, but y'all sitting there and doing nothing is not helping the case. You don't get to play I don't understand and it's teacher fault when you sit there with that look on your faces. You don't get to play that card, because you don't get to play with me. Four over X plus 3, the example up there. Woodland High School is one of the top, is actually, year 4 last, it was the 9th best school in the whole state of Tennessee to learn algebra to do. Pretty good for teaching a bunch of rednecks. I just typed in the equation. I want to look at the graph. It is a weird graph. It is. It's a fractional graph, kids. They look weird. You don't like fractions in the first place. The graphs look weird too. Now, there was something happening here. Did you put parentheses around X plus 3?
Yes. Aren't you supposed to?
No. Did I type something in wrong? No.
That's not true. I got a 1. Yeah, okay. I did the exact same thing.
You have an 83, don't you?
Yeah.
Your 83 is showing the line I just drew in.
On good thing or a bad thing? On
Good thing. Does your graph look right? You just drew an 82. I just drew a line. You just have it already? Where's that line at? -3. This is actually what we call a vertical asymptote. You haven't heard that word yet. It's actually not supposed to be taught to you just yet, but it's coming. We call it vertical asymptote. It's something that you're not crossing. You're not crossing that line. And that is, in fact, where you divided by 0. That's where the vertical asymptote is created. But as far as the domain goes on this thing, X is allowed to be everything to the left of -3 and everything to the right. You know, if you like inequalities, you write it like this. We've used this notation before. All values of X such that X is less than -3 or x is greater than -3. I'm not a huge fan of that notation. Really, really not. It's called set builder. It just uses inequalities. I love intervals. Intervals are easier. This graph runs forever to the left. It goes all the way to -10. It has to jump a wall at -3. It can't actually be -3 because that's where we divide by 0. And it restarts on the other side of -3 and runs forever to the right until you hit what? Then. This is my preferred way, but I'll leave the option up to you. Okay? I don't care how you write it, but that's my preferred. What you got there? A U. Means union. I've been doing this a while. I can't remember if I talked to you all about the word union or not, because every class merges together. It's the interval in the form of or. It's been there because it was on your last quiz. We had to be talking about union.
Well, you kind of just said one day, hey, you need to put a U there.
No, it means the word or. All right, next one we're going to look at, because there's only two rules. There's rule 1, don't divide by 0. Rule 2 we've already talked about. Can't take square roots of negatives. We also talked about the smallest thing you can take the square root of. What was it? 0. That is actually rule 2 on the domain. Now you can take the square root of 1, 2, 3, 4, 5. The deal is you've got to be greater than or equal to 0. But depending on the location, it might just be greater than 7. That's the only two rules you have to worry about when it comes to domain. For even roots, the stuff inside must be either greater than or equal to or greater than 0. Who dat? Oh, it's dog time. Start sweating, kids. Let me pause recording here. Or greater than. If the radical happens to be down in the denominator, you can't say equal 0. You can have a radical in the denominator. When you talk about numbers, no. Function, yes. I don't know what that's there for. That's probably deleted. There's nothing there. So 2 rules. The first one is the most important one, don't divide by 0. The second one deals with radicals and even roots. It specifies even roots. Because can you take the cube root of a negative? You have it here. No, the cube root. Oh.
Yeah.
You've done that in this class. Look at Sean.
Have you ever had a kid get taught in your class?
No. I've had a couple of kids that told me to quit coming to high class whose eyes are ready to be. That freaks them out a little bit. Anything else, they quit coming to my classroom with red eyes. I've never had anybody get caught. All right, so here's a expression. G of x is the square root of 4x minus 2, and we're supposed to state its domain. Now, the deal is you can't take the square root of negatives and be real. So we take the quantity inside and we say it must be greater than or equal to what? Why the 0? Because that's the smallest thing we can take the square root of. That's why the 0. These are actually pretty simple. You just take the stuff inside and you literally say greater than or equal to 0. You make 2-step equations for the most part. What are you going to add? 2. What are you going to do next? Divide by 4. X greater than or equal to 1/2. That's actually written out in a pretty nice form already. The set builder notation said all values of x such that x is greater than or equal to 1/2. Or there's the interval form. We'll look at the graph too, it'll support this. Okay, let's look at the graph now. In the beginning, you kind of need to be looking at graphs to support notation. That's the square root function. I have the button for that, but just out of curiosity, what power would I raise it to be the square root? 1/2. You don't have to do that. I was just going over something. Of course it does. It's an arm. Does it look like an arm? Yeah. It's known as the arm. So you can kind of see by looking at the graph that it starts at about 1/2 and it moves forever to the right. Of course it doesn't cross the x-axis.
It's greater than 1/2.
It actually, sorry, it does. Calculator's not drawing it properly. When x is 1/2, the y value would be square root of 0, 0. It is touching the x-axis. Your calculator's not drawing it. But anyways, its domain, it runs forever to the right. So where does it eventually get to? Infinity. Now it actually starts at 1/2. That's an actual value. We used equality we used an equal sign in our inequality. And it runs forever right to infinity. That's the interval. Rank it 1/2 because you can be that value all the way to the right so you hit infinity. And there's your two notations. First one was set builder, second was interval. All right, now here we got this one that's a little bit harder. Find the state domain of h of x. It's 4x plus 2 over 3x minus 1. And I don't see a radical in that thing. So I just focus on rule 1. What's rule 1? You can't divide by 0. So you got to figure out what that x value is that generates a 0. And it's just as simple as saying equals what? 0. Or if you want to be really peculiar about it, you say it's not 0. That's what it can't be. I like to say that 3x minus 1 is not 0 because it can't be 0. And if it is, poof, there goes the world. God himself cannot divide by 0, people. Anyways, two-step equation. What would x not be? 1/3. That's the only thing. It's going to be 1/3. Now, in the beginning, what you need to do is you need to look at the graphs, so that you can kind of figure out what's going on here. Now I have a commandment on the board that says 2 or more wrap. You don't wrap those, you won't get the right graph. You're not going to have it. Definitely one more. We should see what's called a vertical asymptote at 1/3.
Yeah. That's even weirder.
Well, they get kind of funny.
Ours does. Yeah.
Yours is going to draw the line. We've been through this. So is yours. We've been through this. Yours actually draws in the vertical asymptote, but then you don't get to cross. This thing goes all the way from negative infinity to 1/3, jumps that asymptote, goes from 1/3 to infinity. Now, if you like inequalities,
Do we have to use the other one?
I don't care which one you use. I'm just doing both. I don't care if you identify as a he or a she anymore. I don't care. Just pick one. That's fine. X is less than 1/3. X is greater than 1/3. That's set builder. I'm one or the other. But I can't be what? 1/3. It's easy to figure out what you can't be. It's harder to write what you can be. As an interval, that graph went from negative infinity to 1/3. Couldn't be 1/3, so parentheses on 1/3. And it jumped from the other side of 1/3 to positive there. Hopefully that's enough talk about domains, because that's actually not the point of today's lesson. The point of today's lesson is still composition of functions, which you did a lot of yesterday. You just didn't talk about their domain. I feel you. All right, so we're going to jump up to domain and composition. So I skipped a slide there. What's wrong?
Tired of nothing.
Yeah. What's wrong, Sean?
Trent.
What
You
Trent
saw
do?
my yawns and he's yelling at me because I slept for 12 hours? I passed out at 6. Must be nice. It was nice, I tell you what.
All right, so here we got where we do some composition. Find f of g of x and state its domain. Find g of f of x and state its domain. Find f of x and state its domain. It's actually pretty simple to do. I mean, you guys learned yesterday how to do f of g of x. Everywhere you see an x and f, what do you replace it with? G, which is x plus 7. Now, the first thing I'm actually going to do is rewrite this. Now, f of x is actually 2 over x. Always do those rewrites, kids. Now, that x is going to become what? 2x plus 7. And talk about its domain. Do you see a radical? No, so don't worry about divisions. Don't worry about, that rule. Worry about dividing by what? Worry about dividing by 0. 2x plus 7 cannot possibly become 0. So what can x not possibly be? X is not negative 7x. Now, I'm not going to graph this one. If you look at the graph on this one, you see a vertical asymptote. That is a vertical asymptote. You would see it go all the way close to negative 7/2. The graph would restart on the other side of negative 7/2. So it could be less than 7/2, negative 7/2, or great. I like intervals. This thing would go from negative infinity to negative 7/2. And with negative 7/2 to infinity. When you only got one value, it's pretty much safe just to drop straight on that point. When you got two, you need to be taking a look at it. Find g of f of x and state its domain. This is going the other way around. This is g of f of x. Everywhere I see an x in g, what does it become? It becomes 2 over x. So I started writing g. I write the 2. I see an x. What do I replace that x with? 2 over x. Plus 7. I clean it up a little bit. What's 2 times 2? That's 4 over x add 7. This one's actually pretty simple. There is one value of x that you cannot be. 0. Right there. You literally say x is not 0. Because you can't divide by 0. Now, what might the interval for that thing look like? Negative b to 0. And with 0 to infinity. All right, the last one, kind of interesting one. It's f of x. Everywhere I see an x in f, I replace it with 2 over x. So I have 2 over, there's the x, 2 over x. That's what it looks like on the setup. How do you divide by a fraction? Multiply by the reciprocal. It's great math, kids. This is equal to 2 over 1 times x over 2. Did you flip the denominator? What do your 2's do? What are you left with? 1 what? X. Now, if you looked at the end result, is there a value that x cannot be if you look at the end result? If you look at the end result, is there something x can't be? If you look at the end result, if you look at the very end, could x be 10? If you look at the very end, could x be 10? Yes. Could x be 0? Yes. And I'm talking about the end result, not anywhere else. Could x be a billion? Yes. It's about conception. When this function was created, there was a value x couldn't be. What was it? 0. Now, if you were to graph the original function, I'm going to graph both. I'm going to graph our end result and what we started with. We came up with y equals x. That's just a slanted line. Goes right through the origin. It better be, or all my years of math are wrong. When we conceived this thing, when we made it, we actually wrote 2 divided by parentheses 2 divided by x. It's going to look exactly the same. I promise you it will. It's not telling you that x can't be 0, is it? Okay. Your calculator has a unique function I've never talked about. It's under second calc. It's called 0. It's called value. If you want to know what y is when x is 6, you tell it x is 6, and it's going to spit back a y value. It's going to say y is 6. If you want to know what the value of y is when x is 2, well, you tell it let x be 2, and it's going to spit back, in this case, a 2. I'm telling you x can't be 0, so I'm going to see what my calculator says about the conceived function when x is 0. It says nothing. Domain is found at the point of conception. If x was 0, this function would have been, ooh, here's a bad word, aborted. It would have never made it all the way, kids. If that one little thing had been introduced right then and there, it would have been jumped out the window. So domain is found at the point of conception. Okay, from right there, x is not 0. The graph doesn't show that. That's what we call a hole in the graph. We actually talked about 2 ideas today. We haven't had the lesson on. We talked about asymptotes and holes in graphs. They're ideas. I'm not going to write out the interval, but that's negative infinity to 0, 0 to infinity. What do we got left in here? 3 minutes and a whole lot, but doesn't matter what's left. It's about what we need to talk about. Probably won't talk about that, so let's do this one. This is something that pretty much everybody could do. It's actually a really good EOC type question. It actually does not care about domain nor range. Given f of x is x squared minus 12 and f of x minus 3 equals x squared minus kx plus z, find k and z. Do you have any idea what you might do? Thank God, Sam. Yes, that's exactly what you do. You do what it tells you to do. It says find f of x minus 3. The creator of this problem did it right in his head. That would be me. So, there's an x. What's it become? X minus 3 squared minus 12. Trey, what's x minus 3 squared? Oh, thank God. I was about to yell you so bad. I was waiting for it. I was waiting for it. Yes, you're right. Twice in 4. Anyways, x minus 3 times x minus 3, you'd have an x squared, you'd have a minus 3x, you'd have another minus 3x. So how many x's you taking away? Taking away 6 of them. Plus 9, according to Sean, and Sean is right. 9 minus 12 is 3. No, you weren't supposed to plug it in the other one.
Yeah, I was wondering where you get kx.
By lining things up.
Wait, so k is just 3.
Do you see it?
Found it.
I lined things up. What's k? K is just 6, not negative 6. There's a negative symbol in front of k, isn't there? There's a negative symbol there. What's z? Z is negative. Line things up. That'll be where we stop, and it was more than enough for what you got to do today. Because the big deal about today was domain. That was a big deal about today, domain.
Anyways, enjoy your homework. I made it just for you.
That's so sweet.
That means this is not gonna be something.
What is it?
Math is fun if you enjoy
Don't
math.
need to know.
Huh?
I like doing math.